So first thing, we have what's called the division algorithm, which basically says you can always divide two polynomials. Okay, if f and g are polynomials, and g is a lower degree, and they both have a degree of 1 or more, there is a unique polynomial. What do you think Q stands for? Quotient. What do you think R stands for? Remainder. So another way of saying this is if you divide f and g, you get a quotient plus a remainder, right? The division algorithm is basically undoing that. If you take g times your quotient plus your remainder, you get your original one. This is kind of a confusing way of putting it. I put it up here because it is in your textbook, and I know you guys go home and fact check me and check your books to make sure I'm not lying, right? So I didn't want to just gloss over it. This half of the class doubts me. This half is trusting. So now we know. But it basically just tells us we can divide anything. Okay, it may or may not work out nice. If it doesn't, we have a remainder. No big deal. So if I ask you to divide these, I want to talk about long division first. Ooh, it's been a hot minute, hasn't it, since you did long division? So let's refresh with numbers for a second. If I said I wanted 1034 divided by 5, put that calculator down. What would you do? Okay, can you do 1 divided by 5? Can you do 10 divided by 5?
Yes.
And that would be? 2. And then we take 2 times 5 and we get 10. And what do we do with that? Subtract it off. Okay, so those cancel out, but what do we do next? Okay. And you could go ahead and bring down, since we don't have any digits there, I guess I should. I really didn't want an example that worked out quite like this, but it's okay. Okay, can you do, so we didn't have anything here, so that's like a 0, right? We brought down our 3. Can we do 3 divided by 5? No, so that would be 0. 5 times 0 is just 0. Subtract that off, we get a 3, and we bring down the 4. Okay, what's 34 divided by 5? 6. 6 times 5 is 30. We subtract and we're left with 4. How do we write our remainder? You could do R4. What if I told you I wanted a fraction? It would be 4/5. Okay, so that's kind of our long division you learned way back when, before you got the privilege of using calculators, right? So, let's do the same idea with polynomials. If I tell you to divide them, okay, my numerator, the top is what goes on the inside. My denominator comes out here. All right, so let's think about what we did with our numbers. We started out dividing. We couldn't do 1 divided by 5, so we did 10 divided by 5. Okay, can you do 6x squared divided by 2x?
Yeah.
What does that equal?
3x.
3x. Okay, so that's going to be the first thing I put up here. It really doesn't matter where you line it up. I'm just putting it above my x term to kind of help me keep track of things. Now, once we got that 2 up here, what did we do with it? Multiply it with 5. So that's what we're going to do next. We're going to take our 3x times what we are dividing by, the 2x plus 3. Okay, so 3x times 2x. Okay. Now think about what we did. When I had my 10, what did I do with it? I subtracted it off. So if I want to subtract this off, I am going to distribute a negative through the entire thing. So 6x squared minus 6x squared, that cancels. 5x minus 9x is negative 4x. And then what do I do? Bring down the negative 10. All right. So it's a series of steps. You divide, you multiply, you subtract. We're back to the beginning. We're back to the divide step. So, what is negative 4x minus 10 divided by 2x plus 3? Now really, in that, you just have to look at the first terms. What's negative 4x divided by 2x? Just negative 2, isn't it? Okay, so that's going to give me a negative 2. So then we multiply negative 2 times the 2x plus 3. So if we do that, we get negative 4x minus 6. Okay, then what do I have to do with that? Change the signs to subtract it off. My 4x and negative 4x cancel. Negative 10 plus 6 is negative 4. Can you do negative 4 divided by 2x? Does it work out nicely?
No.
No. I already have my x term, I have my constant term. What's this negative 4 then? The remainder. So typically how we write this is 3x minus 2. Since it was a negative 4, you could put minus 4 over 2x plus 3, or if you put negative 4 over 2x plus 3, that's also fine. Alright. The majority of the problems we're going to do today can be done without doing long division. However, there's going to come a point later in this chapter where we have to be able to do the long division. So that's why I'm going to go ahead and include it now. I'm not skipping over it. We can do this. Got it. Let's do another one. What do you notice about what I'm dividing by? Okay, I has an x squared. So underneath, I'm going to put my 5x cubed minus 4x squared plus 7x minus 2. Outside, I have my x squared plus 1. I am going to write x squared plus 0x plus 1. That is not required. But you notice how I jump from a square down to my constant? If I want things to line up in my subtraction, you can put a 0 there just to help yourself later on. Okay, so if you're missing a power of x, it might be beneficial to put a 0. So now we divide. What is 5x cubed divided by x squared? So that's just 5x. Okay, I'm going to write that above my x term. Then what do? Multiply. You take 5x times the x squared plus 0x plus 1. So 5x times x squared is 5x cubed. 5x times 0x is 0x squared. 5x times 1 is 5x. What do we have to do with all of that? Switch our signs because we subtracted off. Positive 5x cubed and negative 5x cubed cancel. Negative 4x squared minus 0x squared is still negative 4x squared. 7x minus 5x is 2x. And then we have our minus 2. Is everybody with me? Now what do? We're back to the beginning. So we divide just that first term. So I need negative 4x squared divided by x squared. Negative 4. So now we multiply. So negative 4 times x squared is negative 4x squared. Negative 4 times 0x, just minus 0x. Negative 4 times 1, negative 4. What do? Change our signs. So negative 4x squared and positive 4x squared cancel. 2x and 0x will give us a 2x. Negative 2 plus 4 is positive 2. Alright, when you get to this point, we have an x, we have a constant. Can we do 2x divided by x squared? It'll give us, like, we could reduce it, but once you get to the point where this power of x is smaller than what you're dividing by, we're going to stop. That's our remainder. So another way to think of it is after you get your constant, anything after that's going to be a remainder. So we have 5x minus 4 plus the remainder, 2x plus 2, over what I was dividing by originally. And you don't necessarily have to put that 0x in there. You can write it as the x squared plus 1. Alright. Probably not your favorite, but are you guys catching on? Okay. We're going to do one more long division. So, underneath we have our x cubed. We have, I made an extra special problem for us. 5 halves x squared. We have x plus 3. Outside 2x squared plus x minus 1. What's the first step? We divide. Okay, we have to think a little more on this one. I wasn't very nice. What's x cubed divided by 2x squared? 1 half x. So I have 1 half x times what I was dividing by. So 1 half x times 2x squared, which is going to be x cubed. 1 half x times x. 1 half x squared. 1 half x times negative 1 is negative 1 half x. We need to subtract, so we change our signs. Positive x cubed and negative x cubed. Okay. 5 halves x squared minus 1 half x squared. 1x plus 1 half x. 1 and a half. I'm going to write it as 3 halves. And then I can bring down my 3. So now we divide. What is 2x squared divided by 2x squared? 1 plus 1. So then we take 1 times that whole thing. 2x squared plus x minus 1. What do we do from here? Switch our signs. So positive 2x squared and negative 2x squared cancel. 3 halves x minus 1x would be a 1 half x plus 4. Alright, am I going to be able to go any further? No, I already have my constant up here, plus I look, this power of x is smaller than that one. Alright, so my answer, 1 half x plus 1, plus, if you did your remainder over what we were dividing by, is that proper notation? No, we don't like a fraction in a fraction, do we? So, an easy way to eliminate it. What'd you say? Somebody said it over there. If you want to get rid of this, we just have to multiply by the denominator, but you have to do it on top and bottom of this fraction. Okay, that way we're just multiplying by 1. So 1 half x times 2 is just x. 4 times 2 is 8. Over 4x squared plus 2x minus 2. Alright. So that one was significantly uglier due to the fractions. But the same general process, and I wanted you to see that it's okay to have fractions in our division. We can still work through that. Are there any questions there? Okay, so as we go through this chapter, we're going to have a lot of division to do. And this works, but it's time consuming. In certain cases, there is a shortcut. So that is synthetic division. Now, we can't only do synthetic division because it doesn't always work. It only works if you are dividing by something linear, like x minus a number or x plus a number. So in the previous problem, could I have done synthetic? No, that's not linear. We couldn't have done it. This one's not linear, so we couldn't have done it. But most of the problems we're going to encounter in this problem, we are dividing by the linear thing, so it would work. So you have seen this before. Let's see if we remember it. So remember, you set it up, and in synthetic, we basically drop out all the x's. So out in this box, we have to put the 0. What would make x minus 4 equal 0? 4. So I put a 4 here. And then I'm going to put my coefficients. So we have a 3. We have a negative 2x squared. Do I have an x to the first? No. So what do I put for that? 0 minus 150. You have to account for every power of x. So we go 3, 2, 1, 0. All right, now it's the same essential steps from our division. The first number comes all the way down. Okay. So then you multiply. What is 3 times 4? 12. And then we add. Negative 2 plus 12. Okay, so it's just a series of multiply and add. So 10 times 4, 0 plus 40. 40 times 4, negative 150 plus 160. Okay, when you get to the end, this final number is your remainder. This is your constant. Then it's just increasing powers of x, so like x and x squared. So my answer is 3x squared plus 10x plus 40. And then how would I write my remainder? Did I lose anyone? Let's try another one. I want to show that x plus 3 is a factor. Factor just means it divides evenly, so there's no remainder. Right, so if I want to divide, I have to first look at what I'm dividing by. What makes x plus 3 equal 0? And then we put our coefficients. We have a 2, 5, negative 2, 2, negative 2, and 3. I don't have any zeros here because I had every power of x. 5, 4, 3, 2, 1, 0. How do we begin? First number comes all the way down. And now it's just a series of multiply and add. So 2 times negative 3, 5 plus negative 6, negative 1 times negative 3, negative 2 plus 3, 1 times negative 3, 2 plus negative 3, negative 1 times negative 3, negative 2 plus 3, 1 times negative 3, 3 plus negative 3, 0. This time I didn't even ask you what the quotient was. I just said, show me it's a factor. So this means the remainder is 0, which means it's a factor. It divides evenly without any remainder. Do you guys remember doing synthetic division before? Are there questions for me so far? So, couple things to remember. Synthetic division, we have to do a linear factor. I put on your paper with a coefficient of 1. We'll get more into that later. You can still divide if it's not a linear coefficient of 1 as long as you find the correct 0, but you would have to alter your quotient a little bit. So right now we're just talking about the cases where it's linear with a coefficient of 1. When you do that, you have to include zeros if you have any missing powers of x. You can't just skip over them because we're leaving all the x's out. It would change things. So don't forget zeros. And the last one is always your remainder when you do that. So a couple other things. This is kind of, the remainder theorem is kind of a cool shortcut. If all we care about is the remainder, it actually works that your remainder is equal to f of k. Okay. In other words, if I go back, everybody grab a calculator for me. So we were dividing by -2, right, when we did this? What I want you to do is on your calculator, plug in -3 for all of these x's. You have to put parentheses around them. Just type the whole thing in your calculator. What do you get out? 0. Is that what we got for our remainder? Yes. So if I ask you if it's a factor, you could plug it in and see if you get 0 for your remainder, or you can do the synthetic division. Both ways will work. Okay, it's just whatever you're comfortable with. The final thing is if I mention a 0, zeros are kind of like factors. So if I say check if 5 is a 0, I'm saying check if it divides evenly. So when I put in 5, do I get a remainder of 0? So I just want to do a few last problems, and then I am done for today. All right, so if I want to decide if 2 is a 0, we have 2 options for doing this. Can you tell me one of them? Plug it in. And I heard someone else say synthetic, so those are the 2 options. I'll do both of them on these problems. So if I just put in a 2, what does that give you? What did you get?
-8.
Right. -14. So that means if I were to divide this, my remainder is -14. So is it a 0? No. All right, B, let's do that the other option. What did you tell me was the other way of doing it? Synthetic. If I give you k, that's the number that goes out in your box. And so then you do your coefficients. We have a 1x to the 4th, -4x cubed, -14x squared, 36x, and 45. So I can do synthetic. Bring down my 1. 1 times -3 is -3. -4 plus -3 is -7. -7 times -3 is 21. Plus -14 is 7. 7 times -3 is -21. Plus 36 is 15. 15 times -3 is -45. Add them and we get 0. So is this a factor? Yes. I do not care. If I ask you if it's a 0, I don't care if you do the division or you plug in the number. Either one is fine. All right. Last problem of the day. I gave you an imaginary number. We're going to be finding lots of zeros of polynomials. They're not always real numbers, so we need to be able to deal with imaginaries. Now, can I just use my calculator to plug in an imaginary? No. So this one is probably a case where we want to do synthetic. So the 1 plus 3i goes here. My recommendation, space out your coefficients a little more when you write this. We're going to need a little extra space here. Okay, what am I looking for ultimately? If it's a 0, we have to have a 0 for a remainder. Okay, so the 1 comes down. You multiply. What is 1 times 1 plus 3i? Okay, what is negative 1 plus the 1 plus 3i? Now you're multiplying. You're taking 3i times 1 plus 3i. But remember, we've done complex numbers in here, so this isn't new. If you distribute, you get 3i plus 9i squared, but 9i squared is negative 9, so 3i minus 9. Combine like terms, positive 6 and negative 9 would be a negative 3 plus 3i. Okay, now I have to do negative 3 plus 3i times 1 plus 3i. So we need to you get negative 3 minus 9i plus 3i plus 9i squared. 9i squared is negative 9 plus negative 3 would give me a negative 12. Negative 9i and positive 3i is negative 6i. Okay. Not beautiful, but we're almost done. When you combine like terms, 14 plus negative 12. So now we have one final multiplication. So 1 plus 3i times 2 minus 6i. 1 times 2 is 2. Minus 6i plus 6i minus 18i squared. What happens to my 6i's? Negative 18i squared is positive 18. 2 plus 18 is 20. And we get 0. So is this a 0? Yes. It divides evenly.